11.6, 11.6 inverse variation, Algebra 1. We're going to be using the equations y is equal to k divided by x, or if you solved it for k, it would be x times y equals k. All right, so let's get started. All right, so recall, we're going to have to go back and talk about direct variation first so we can make sure we understand all of that again because it kind of goes along with this. Recall that a direct variation equation, when you graph that, it went directly through the origin, whether it was a positive slope or a negative slope, because you could possibly have it going this direction if it was a straight line. You could have it going that direction also and be a direct variation as long as it goes through the origin and is a straight line. The equation for a direct variation is y equals kx, or if you solved it for k, y divided by x. And it's really important to know both directions because this will help you understand what it is you're doing when you have a table or order pairs. Okay, k equals y divided by x. That means you always will put the y over top of your x and see if there's a ratio. All right, so when we were looking through this, of course, you know we talked about this being through the origin, so yes, this is a direct variation. When you're looking at tables, however, you need to take each one of your y coordinates and divide it by your x. That's why I say this formula right here is really important to know. So if I took 6 divided by 3, excuse me, let's go back, can't read my paper, 6 divided by negative 2, and is that equal to 3 divided by negative 1, is that equal to negative 9 divided by 3, is that equal to negative 15 over 5. All right, so you have to go through each one of these to see if they all have the same rate. All right, if you divide 6 divided by negative 2, you will get negative 3. 3 divided by negative 1, negative 3. Negative 9 divided by 3, negative 3. Negative 15 divided by 5, negative 3. All of these have the same rate. Okay, so that means k is negative 3, which is your constant of proportionality. So all of these had the same rate when you divided for a direct variation. So think about direct, divide when it comes to finding out the ratio. Okay, they all had the same rate, so that is a direct variation, and the k constant is negative 3. In a direct variation table, like I said, you will divide the y's by the x's. Now, something else you need to also understand with a direct variation, as the x value increases, okay, the y value also increases. Okay, so as x goes up, so does the y. But also, if x decreases, then the y's decrease. Okay, so it goes both ways. If it's going up, they're both going up. If it's going down, they're both going down. Think of this in terms of more equals more, or less equals less. That'll help you when you're working with word problems to understand which one to use. More equals more or less equals less is a direct variation. And you'll see what we're talking about in just a moment. All right, but in an inverse variation, as the x value increases, the y value goes down, decreases. And vice versa, as the x value decreases, the y value increases. So with this one, you want to think more equals less or less equals more. Okay, so it's one going up, one going down. And that equation for the inverse variation is y equals k divided by x, or solving, we should have had this one solved for another variable. This one should be, hold on, let's change this. Whoops, let's make this. This should be k, now you can't see it. This should be k equals yx. Okay? This one is wrong. Do not look at that. All right, y equals x. I had several equations going on at once. All right, so k equals y times x. All right, so This one is the one you want to look at when you're looking at your tables, because that variation is where your y is multiplied to your x, okay? Whereas direct variation, your y is divided by x. In this graph, y is equal to k divided by x, and this is what the graph looks like, and that's totally different from your direct variation graph, where it went through the origin. This does not come anywhere close to the origin. Okay, one is going down like this, and one is going up like this, and vice versa. If you had a negative k on the top, then this one would be going up, and this one would be going down like that. Okay, so this should be k equals y times x. Sorry for that mistake, I just saw it. In an inverse variation table, the relationship between the x and the y's are that they are multiplied and get the same rate. All right, so the constant k is determined by multiplying the y times the x. So if the answer is the same, it's an inverse. If it is, when you divide them and they're the same, that's a direct. So notice you'll multiply 3 times 85, 5 times 51, and 17 times 15. They all produce 255. So that tells you, because these all worked out to be the same ratio when you multiplied, that it's an inverse variation. Okay? So you'll be given tables, and you're going to either divide the y's by the x's or times the y by the x's, and if there's the same rate, you'll either know it's direct or inverse. All right, so we want to determine with application problems whether it's a direct or an inverse. Okay, this is very important because you're going to be given just random real-life problems, and you're going to have to know what to do with it. But remember, if you'll think about a direct variation is more equals more or less equals less, and an inverse is more equals less or less equals more, you will be able to figure these out without any problem. All right, the cost of a $120 boat rental is split among several friends. Is that a direct or inverse variation? Okay, let me ask you this. If you had a $120 boat rental and you only have 2 people splitting that, that would be 120 divided by 2, which is 60. Say you had 5 friends or 6 friends, let's say 6. 6 friends that were going to split that rental. Okay, if you only have 2 friends, that was going to be $60 each. But if we have 6 friends, that would equal what? 120 divided by 6 is 20. All right, so 2 friends and you have to pay $60. 6 friends and you have to pay $20. So which one is this? Is this a direct or inverse? Well, this one means the more people that are going, the less money you have to spend each person. So this is definitely an inverse variation. Okay? The more people that go, the less money you have to take and pay on yours. Now, this one says downloading music or movies at $14.99 each. Okay? Each movie is this. Okay? And we're downloading X number of movies. It doesn't matter. There's still going to be $14.99 each. Whether I download 20 or 1, it's $14.99 each. So this would be a direct variation. So in other words, if you spent and got 20 movies, you'd pay a lot more than if you bought 1 movie, and it'd be $14.99. So that's a more equals more or a less equals less, depending on the number of movies that you've downloaded. All right, you buy several sweaters, and they're $35 each. So in other words, it does not matter if you buy 1 sweater or 20 sweaters, it's still $35 each. That, again, is a direct variation. Okay, you walk 5 miles each day. Your speed and time spent walking vary each day. All right, so you're still going the same amount each day, 5 miles, but you could do it in 20 minutes or you can do it in an hour, okay, depending on how fast you're going. So if you walk slower, it's going to take you more time. So this one is an inverse variation because your time and your speed vary. All right, the perimeter P of an equilateral triangle with side length S. There's the formula for that. Okay, is that inverse or direct variation? Well, they give us a formula, but every single side of an equilateral triangle are the same, so that doesn't change. So the only thing that you've got is your perimeter. So this one be a direct, direct variation. All right, the time to travel 150 miles at a rate of miles per hour or miles per hour. Okay, depending on how many miles per hour is how long it's going to take you to get that 150 miles. So in other words, if you drove super, super fast, you could get there in a lot less time than if you drove 15 miles an hour. Okay, so this would be well, more equals less or less equals more kind of thing. That's an inverse. All right, how about the circumference of a circle with the radius of r? Okay, so the radius is going to be the same in all through the circle, right? Okay, so the circumference is based on the radius alone. All right, so if we wanted to solve this for r, we would say c divided by 2 pi. Okay, so this would be, depending on, well, if we were comparing two different circles, this could be an inverse variation, but the radius on one is going to be a direct variation because the radius is the same throughout the circle. Okay? It is directly related. Now, if you were given ordered pairs like this, remember what we did with the table where it was a direct variation, we divided the y's and the x's. But if it was an inverse, we multiplied the y's and the x's. We need to see, given these points like this format, if it's a direct or inverse variation. So if I took and divided the 5 divided by 3, does that equal 15 divided by 1? No. So let's see if we can, that would have taken care of direct variation. Let's see if we multiply them. 3 times 5, that's going to give me 15. And 1 times 15, that's going to give me 15. So I multiplied, which means that has to be an inverse variation because I multiplied the x and y's and got the same rate. When I tried to divide the y's and x's, I did not. So this is an inverse. All right, let's try this with this ordered pair. If I multiply the two, I get negative 12 and negative 27. So when I multiplied, it did not work. So that rules out inverse. If I take 6 and divide it by negative 2, does that equal negative 9 divided by 3? 6 divided by negative 2 is negative 3. And negative 9 divided by 3 is negative 3. So because I divided, it is a direct variation. Okay? All right, and I think I have one more slide. Yeah. Suppose y varies directly with x. Okay, write the equation. So it says in there that it's an inverse variation. Inverse variations are y equals k divided by x. So it says, suppose y varies inverse with x, write the equation. There you go. All right, this one says, suppose x varies directly as y. All right, so we're going to be x varies directly. That's going to look like this, and of course you have your k in there for your constant. This is an equation of a direct variation. Most of the time you'll see it written with the k right beside the equal sign. Okay, but they're the same thing. All right, now let's talk about these and see if we can solve this one. 4 people can paint a house in 3 days. How long would it take a crew of 5 to paint the same house? Now, think about it. If you have 4 people painting a house in 3 days, do you think it's going to take more time or less time if you have more people? It should take less time. So this would be a more equals less, which means it's an inverse variation. So that means you would write y is equal k over x. All right, so we have to find k first. So we're going to plug in what we've got. 4 people, that's going to be your y, can paint a house in 3 days. All right, so we don't know what the k is, so we're going to say 4 people, we don't know what k is, in 3 days. All right, when you solve for k, you multiply these two, and that's going to be k is equal to 12. All right, now it says, how long would it take a crew of 5 people? Okay, so 5 people, and we know what k is now, and we don't know how many people. Okay, excuse me, we don't know how long. So we have 5 people equals 12 divided by x. So let's see, it takes 5 people to paint the same house. And we've got 12. And let's see, we're going to now multiply. So we're going to have 5x equals 12. And then divide by 5. So x for 5. X is going to be, let's see, it's going to be a decimal. 12 divided by 5. 2.4. 2.4 days. Which makes sense because it said 3 days for 4 people. It'll take 2.4, which is less days for more people. So there you go. All right, the next one says Kelsey runs for 20 minutes and burns 200 calories. Okay, and then if she runs at the same rate for 30 minutes, how many calories would she burn? Okay, so when you're talking about exercise, and the longer you exercise, what happens? That's right, you burn more calories. All right, so that would be a more equals more, which is a direct variation. And especially because it says the same rate. So if it's the same rate, you know it's going to be direct. All right, so when we set this up, we're going to have 20 minutes equals k 200. Okay, so we have to find k, so we're going to divide by 200. We should put over here y equals kx is our direct variation equation. All right, so then when we get k, right here, so we're going to have 20 minutes divided by 200. That's 0.10. All right, so now it says, if she runs at the same rate for 30 minutes, how many calories would she burn? All right, so 30 minutes equals, now we know what k is, 0.10, and we're doing, we don't know how many calories. All right, so now we're going to take and divide by 0.10. And I'll put this over here. X will be 30 divided by 0.10. Whoops. 30 divided by 0.10 is 300 calories. Okay, and that's our answer. So yes, it should be a bigger number because she's exercising for 10 minutes longer, so she should be more than 200 calories. So if for an extra 10 minutes, she burns another 100 calories. So that's a direct variation. All right, so we will work on problems in class. If you have any questions, come see me. But the key to these variations is to understand more equals less or less equals more is inverse. More equals more or less equals less for direct. Okay? See you in class.